Okay, this is the third part of the January 2007 MF or N5 module paper 1, and this time we're going to move on with questions 8 onwards. So if you could have a look at question 8, have a go at that, and then we'll go through it in a minute. Okay, so going through the solution to question 8, we've got a spinner and a coin, and what are they telling us? Spinners from numbers 1 to 6. The coin is a fair coin. That means it isn't biased. It will have an equal chance of falling on heads or tails. And they toss the coin and spin the spinner, and they want you to complete this. They call it a two-way table. Also in maths it's called a sample space diagram. Either way, hopefully you can remember how to fill in all the possible outcomes or the results whenever you spin the spinner and toss the coin. So here we've got all this row here is all where we're getting a head on the coin. So you can get a head on the coin and a 1 in the spinner, head on the coin and a 2 in the spinner, and so on. And then this row here gives us the outcomes or results whenever we get a tail on the coin. So tail and a 1 on the spinner, or we could get a tail on the coin and a 2 in the spinner, and so on. So you get 2 marks for filling in the table, and obviously recognizing that there are 12 possible outcomes or results. So there's 6 in this row and 6 in this row, so there's a total of 12 possible outcomes or results. So then the second part of the question then asks us, what's the probability of getting a result or an outcome which is a head and a number greater than 3? So we're going to look at our two-way table and see how many of the results include a head and numbers greater than 3. So that's 4, 5 and 6. So we've got head 4, head 5 and head 6. So there's 3 results meet that requirement, and the answer then is 3 out of 12 is the probability of getting that result. You can't simplify that to 1/4, but either of those answers will give you the 2 marks. Okay, so have a look at question 9 and try it. We'll go through it in just a few seconds. Okay, question 9. So here they're asking us what the average speed is. So the important thing here, we're given a certain number of miles and we're given a time. And we need to remember your distance, speed, time formula triangle. And if you can remember that, then hopefully you'll be able to find that speed is equal to distance divided by time. Now there's a couple of ways of doing this. Usually if you're dividing 315, which is the distance, if you're dividing that by 4.5, which is the time, the 4 hours 30 minutes, normally we would ask you to multiply the top and bottom by 10 to try and get rid of this decimal number here. So you would multiply the top by 10, gives you 3150. Multiply 4.5 by 10, changes that to 45, and then you could start looking for numbers that divide into the top and bottom. So 5 divides into 45, goes 9 times. 5 divides into 3150, which is 630, and then 9 divides into 630 to give you the answer 70. Possibly an easier way to think of this is 315 miles in 4.5 hours is the same as, we're going to multiply both sides by 2. So that's the same as 630 miles in 9 hours. So all we've done here is multiply those two numbers by 2, and now we've got 630 miles has been travelled in 9 hours. So the formula says distance divided by time, and that gives us our answer 70 miles. Okay, so here's question 10. If you have a look at that and have a go at it, then we'll give you the answer in a couple of seconds. Okay, so for question 10, this is one of these ones where they're asking to investigate like a number pattern to decide whether it's always even, always odd, or it could be odd or even. And they want you to look at this 4n plus 2. And the solution to these is to take different values of n and see whether the answer comes out to be odd or even. So if you look at 4n on its own, 4n, if n is equal to 1, 4 times n would be 4, 4 ones are 4. If n is 2, 4 times 2 is 8. If n is 3, 4 times 3 is 12, and so on. So all those answers, 4n is always going to give you an even answer. So then if you add another even number, 4n add 2, if you add another even number to an even number, you still end up with an even number. So in this case the answer is always even, and the reason is because 4n is always even, so 4n plus 2 must always be even. Okay, so this is question 11. So if you want to stop the video and have a look at that, and we'll go through the solution in a few seconds. Okay, so for question 11, part A says describe the transformation which maps, that just means moves, shape A onto shape B. Now the thing to notice here is that this shape A has been flipped over, and that's a good indication that it's going to be a reflection. So if you can imagine, if you can get tracing paper, you can see that from that. I've traced it onto the tracing paper. If I turn the tracing paper over and move it over to here, you can see that shape A has been flipped over and to make shape B, and that tells you it's reflection. To find out where the line of reflection is, you're trying to find halfway between the two shapes. So from this point to this point, if you count the squares, it's 6 squares. So the mirror line is going to be halfway between. You draw a nice straight line down along that line there. And now you have to give the equation or the rule for that line. So you need to remember this line crosses the x-axis. It crosses it at x is equal to minus 1. Well, the rule for this line is x is equal to minus 1. So for this answer, you've got to give two pieces of information, and that is the word reflection, and you need to give the mirror line, which is x is equal to minus 1. The second part of question 11 then is what's the transformation which maps or moves shape A onto shape C. Right. In this case here, hopefully you can see that shape A has been turned around. It's been rotated to end up as shape C. So in this case again, you need to get some tracing paper. You need to trace shape A. So put your tracing paper down on top of shape A and trace it. Then we're looking for a point on this grid here that which is the center of rotation. Probably a good attempt every time is to try this point, the origin, 0, 0. So if you can imagine holding your pencil on the tracing paper at the origin and turning the tracing paper around, and hopefully you can see that shape A rotates around and it lands exactly on shape C. So to find out how much has it moved, if you put a little arrow pointing upwards with a little arrow sign there, whenever you rotate shape A round to shape C, you can see that this little arrow here has rotated 90 degrees. So the answer in this case then is going to be, you have to give three pieces of information for this answer here. You need to use the word rotation. You need to give the direction of rotation and the amount, which is 90 degrees in a clockwise direction. And the last thing is, where was the center of rotation? Where did you put your pencil on to hold the tracing paper? And that was the point 0, 0, or the origin.